I get to usher you down the proverbial rabbit hole to the global plastisphere. But before we start, just to quote The Matrix, I'm only offering you the truth. So let's see just how far down the rabbit hole this goes. We have a problem, and that problem is plastic in nature. And though that pun is well-timed, it's also quite true. Since the 1950s, we have created, industrialized, and commercialized a polymer, a plastic, which refers to an entire suite of polymers that has modernized this world and allowed us to live in every conceivable manner imaginable. In fact, all of you sitting here, those listening right now, or watching on a streaming service, could not do so without some form of plastic. It's almost impossible to escape the reach and effect of this compound that has shaped our present reality. And though it is great to live in this modern world, there's another side to this scenario that we didn't foresee. It's been looming just at the forefront of our sight and lurking just beyond the grasp of our imagination. Something we didn't expect and far less predicted. As of today in 2023, we have produced essentially 9.2 billion metric tons of plastic. 9.2 billion. Think about that for a moment. To visualize, that's at least 27,000 Empire State Buildings of pure plastic. Pure plastic. Air ducts, pipes, windows, toilets, everything is plastic. And as impressive as that may sound, 70% of all that plastic is directly in the environment in some form or manner. How did we get to this point? How did it happen? Well, to answer that, we gotta go back, way back to the mid-20th century. Now, the history of plastics is actually quite interesting, and I urge you to look further into it when you have time. But for right now, I'm gonna focus in on a key phase that was essential to shifting societal and environmental dynamics. Prior to the 1950s, we had the creation of Bakelite as the first fully synthetic polymer. The 20s saw PVC, many of you know it. It was key to structural and infrastructural components, and it's still widely used today. In fact, homes today are probably more plastic than they are wood, as you can see here. The 30s, not to be beat, saw an uptick in polydiversity with the creation of nylon for toothbrushes and military gear. America's national pastime also got a boost with the creation of polystyrene and high-impact polystyrene. I wonder what he's binging. Now, plastics were also critical to World War II and the success of the Allies. It's with the creation of PET and Teflon, because Teflon was the only material capable of housing the atomic bomb without reacting. So now you know to add Teflon-coated frying pans to your zombie apocalypse survival kit. But after World War II, we saw a massive ramp up in plastic production, and it was the result of a concerted and an effortless campaign that is considered the most successful commercial campaign in history. Plastics were now being marketed towards the middle class as a way to improve everyday life, your comforts, and to provide excess. It was to this point that during the 1950s, at one of the world fairs, the flagship for this plastic campaign, impressive enough, was Tupperware. Tupperware was the flagship and the mascot for the targeted molecule of tomorrow, which were plastics. And I like to think that it went something akin to the scene in Captain America where Howard Stark is at the world of tomorrow, and he's trying to impress everyone saying, we don't need roads. So the people take off the wheels off of the car, and it starts to levitate, and everybody is amazed. But instead of Howard Stark in a car, it's Earl Tupper standing at a table with a tablecloth. He lifts it up, and it's Tupperware. And everyone's like, oh my gosh, this is great. And then when we fast forward here now to 2023, we use plastics for everything. Everything from traveling the distance cosmos of the universe to something as mundane as holding the plastics that have plastics from the environment. We are witnesses right now to the success of that campaign that started in the 1950s. It's to that end that 2.1 billion metric tons of plastic has been in the environment since that industrial ramp up. 2.2, to which 50% of that are single-use plastics, which I see everyone here has a little bit of single-use plastic on them. But why that matters is because that means that at least 1.1 billion metric tons of plastic was literally designed to be discarded after its initial use. Crazy. And what's more is that this doesn't just stay somewhere. It's not happening out of sight. It's everywhere. It's everywhere around. It's not in some wasteland, not in a dump somewhere. We see it. And as scientists, we're playing catch up to this. Because plastic does not stay still when you discard it. No, it moves, it migrates. And as it migrates, it interacts with the abiotic and biotic aspects of nature. It fragments into smaller and smaller pieces until it's categorically what we call a micro or a nanoplastic. And here's the core of that issue. Micro and nanoplastics are everywhere. Actually, as we study, we find that they've been there for some time. And over the last 10 years, slowly the unveiling of the global plastosphere has been coming into view. Welcome to the plastosphere. Plastics originate in cities where they are mobilized from precipitation, forms of rain, snow, hail, any form. Once there, they move. And when they move, we see them. Where do they go? How long does it take them to get there? What will they look like when they get there? Will they meet up with other plastics by that time? And when we find them, I should say, if we find them, will we recognize them? But what we know is that from these waterways, they're on the move because every freshwater system that we have studied and looked for micro or nanoplastics, we've found that they are there and they've been there. It doesn't matter whether it's a drainage ditch, whether it's a manipulated stream, or a more natural river. We seem to find out that these waterways serve as plastic superhighways. Now, where do these rivers and waterways take them? Well, a large percentage of them will make pit stops. And they'll make pit stops that could happen in your wastewater treatment facility plants. Some of them may actually just get deposited into the sediment and stay there. But those select few, like the elusive salmon, that makes their journey all the way back to the ocean. I'm joking. What happens to them is they look very different than when they started and may be unrecognizable from the substrate you find them in. Such as my two sons here trying to tell the difference between polyethylene nurdles and microfragment beads from the sand. Now we know that from the last 20 and 30 years, what happens with plastics in the ocean? That's a big trigger. We understand that. They can either float in the water or they'll sink as they get colonized by microorganisms and other organic matter and sink. And we used to think that that meant it was an ultimate sink, that they would sink there and stay for at least a few decades, if not longer. Put a pin in that and remember, because I said we thought. In 2020, Dr. Janice Brainey of Utah State University, just so you know, there's a difference. She published about microplastics in rainfall deposition. And this was the first time revealing that micro and nanoplastics could transport by the wind and the rain. In 2022, Dr. Alex Aves of the University of New Zealand published microplastics being found in freshly fallen snow of Antarctica. And in 2021, Thomas Nordstrand, a fellow doctoral student and myself at UTSA, found microplastics in hail. This means that the atmosphere is acting and serving as a reservoir for micro and nanoplastics. This is something that was never foreseen. It has implications on climate dynamics, on environmental components, on weather dynamics. It also has potential influence on our carbon budget and on the heat radiative impacts that we are studying in climate change. Part of the equation we didn't even fathom. Now, we also know that plastics are in the ground. They've already been marked as a point for the Anthropocene, but they can look very different, as you can see my undergrad here, depending on where and when you look, and then how far down you dig. And we've also found micro and nanoplastics in living tissue. Whether it be animals of air, land, or sea, when we look for them, we are finding that they are there. They're in our vegetables. They're in our fruits. And yes, they're in us. Whether it's your digestive tract, your lung tissue, your mammary gland, or the placenta. We found them. The impacts of chronic exposure by micro and nanoplastics are currently being investigated by the World Health Organization and by the NIH. And in 2022, most recently, Dr. Fernanda Avalar-Santos published in the Marine Pollution Bulletin plastic rock as the shoreline in remote volcanic islands in the Southeast Atlantic Ocean. Now, where did that come from? Remember I said put a pin in the ocean, we thought it would be there, it's ultimate sink? Well, some of that plastic is getting pulled back up by upwelling, and it's now being integrated in a natural geologic process for the formation of rock. It's as if plastics are cycling the planet akin to a geochemical cycle. What's that word for astonishment, really quick? What's that word? Whoa. Whoa. Or maybe, oh crap. For perspective, all other biogeochemical cycles took billions of years to create, but this plastic one seems to only have taken about a century to start emerging. To add, the evolutionary scale that is being influenced by our plastic pollution, waste, and discardment has now started to show that it might be emerging as a selective pressure on microbes in different parts of the environment and of the world. Talk about human ingenuity and legacy. This is something that hasn't been done before, guys. Now, I know that this can also seem a little scary, a little unwieldy, but I want you to know, remember, this polymer was marketed as the molecule of the future. Thanks to recent research, we are finding out that microbe communities around the world are showing evolutionary traits with minute capabilities to metabolize different forms of plastic. The ability to mimic that and industrialize it is currently underway. Fungal enzymes, the master decomposers of the world, are starting to reveal that they also have biodegradation capabilities for polyethylene and for PVC. Implementing that right now in waste management is possible. But it doesn't stop there. The success of plastics at this point is only a result because the campaign continuously pushed the possibility that the flexibility and mutability of plastics can serve as the nexus to human imagination and innovation to meet reality. We can do that again. Recycling infrastructure can be improved. In the Hutchinson Lab, we propose using a nested concentric circle base that is founded upon single-use plastic waste and use for recapture and reinvention. Additionally, plastic infrastructure, recycling plastic infrastructure, can be improved when we start using true economic strategies that are circular in intent, but not with one that points out how we fail to see this point right now, but rather that provides a vision of what the future can look like with true plastic mastery. So right now, everyone, mankind, we have a testament to our stance in the universe. We have created a new biogeochemical cycle, and they don't disappear. They don't go away, so give yourself a pat on the back. But I want you to remember, to solve this, We must launch a campaign that rivals that of the 1950s, one that does not show how we got here with failure and glimpses or lapses, but rather one that gives a vision to the populace of what is possible with plastics, not without them. We aren't getting rid of them. So let your innovation, let your imagination, let your passion, and let your collaborations work to meet the expectations for this task. Or, in the words of Tony Stark, remold the future, but this time using the molecule of the future. Thank you.